In this final lesson, we're going to take a look at variation. There's two types. There's direct variation and there's inverse variation. So it'll say in the sentence, it'll say y varies directly as x. And that would look like this. And then in the second type, it'll say y varies inversely as x. So it spells it out for you whether or not it's inversely or directly. And the difference is the equations you're going to use. So we're going to use these equations, y equals kx or y equals k over x. K is a constant that we are looking for. We need to figure out what k is for each one of these problems. So let's take a look at our first example. We have direct variation. It says if x varies directly as y and x equals 9 when y equals 3, find x when y equals 12. So basically each time you're going to need two equations. The first equation, you just plug straight in your y equals kx. Okay? We know that when x is 9, so we put a 9, times some number, that the outcome is 3, using this formula. Okay, so we've got 9 times something, k, equals 3. So what we have to do is figure out, well, what's k? And you figure out what k is by dividing by 9. And you get k equals 1/3 if you reduce, because 3 over 9 reduces to 1/3. So k is 1/3. Now that I figured that out, I have two things to plug into the second equation. I get, again, I use the y equals kx, and I put the 12 in for y, so I say 12 equals 1/3 of x. Okay? Well, all we have to do is find x for the second type, saying x is what when y is 12. So all we have to do is get x alone in the second equation. And I do that by multiplying by 3. And if I times it by 3, I'll get 36. X equals 36. So that means when y is 12, x is 36. Okay? So the goal is you write two equations. So step 1 is two equations. And then the second step is you find k. And the third step is plug into second equation and find variable. So that is the whole process for variation. And it works for inverse variation as well. But this problem is not inverse variation, it's direct variation. But this time there's a square. So it says a varies directly as the square of b. So what the equation looks like is a equals kb squared. Okay? K times b squared. So a equals 4 when b equals 3. So what that means is my first time is that I've got 4 is equal to some number times 3 squared. Okay? And we've got to remember that the b is squared this time. So that's our first equation. The second one says find a. So what does a equal when b is 2. So I want to put 2 squared. So all I have to do is find k, and I just have to multiply it by whatever that number is, and I'll have a. So I do that over here on the left-hand side by solving for k. Well, 3 squared is 9. So if I divide that from both sides, that gives me k equals 4/9, which reduces to, well, it doesn't reduce, sorry, 4/9. Okay? So that's my k. So now I take that and I plug it over here for k. And that's going to give me a equals 4/9 times 2 squared, which is 4. So the answer for a is that a equals 16 over 9. And it just so happens that this doesn't reduce very nicely, but that's alright. So a for my answer is 16 over 9. Now we're going to look at inverse variation. This one says m varies inversely as p squared, and m equals 20 when p equals 2. Find m when p equals 5. So our formula will be that m equals k over p squared. And then we just have to plug in our numbers. So our first time it's going to be 20 equals k over 2 squared. The second formula is going to be, we want to know what m is, equals k over 5 squared. Okay? So we just work it out. This is 4, so I times by 4 to both sides, and I get K equals 80. So now that I have K, I put it over here. So that means I get M equals 80 over my 5 squared, which is 25. So all I have to do is reduce to find M, and if I divide the top and bottom by 5, I get an answer of 16 over 5. And that's my final answer for what M is when K is 5. Or sorry, P is 5. Now we're going to take a look at two word problems. This one says the distance of a body falls from rest varies directly as the square of the time it falls. So what that means is the distance will vary directly, so K, as the square of the time it falls. So I take S and square it. So that's the formula I'm looking at. That's direct variation. So a skydiver falls 64 feet, so 64 feet in 2 seconds. So I say K times 2 squared. How far will she fall in 8 seconds? So that means I want to figure out the distance, whatever my K is, that's what I need to figure out, times 8 squared. So all I have to do is figure out what K is by dividing both sides by 4 over here on the left. And if I divide that, I should get that K equals 16. So now I know what K is, so I can take it over here and plug it in on the right side. So now I just have to work this out and get D equals 16 times 8 squared, which is 64. So if I take 16 and times it by 64, I should get D equals 1,024. And that's the total distance in feet that the skydiver falls after 8 seconds. So let's do one more problem. This one's varying inversely. So it says the current in a sample electrical circuit, so current varies inversely, so equals K over the resistance. If the current is 20 amps when the resistance is 5 ohms, find the current when the resistance is 7.5 ohms. So I just plug it in the formula that I created. So current is 20 amps equals K over resistance, which is 5. In my second equation, I want current equals K that I want to figure out over my resistance, which is 7.5. So all I need to do is figure out what K is. So I multiply the left equation by 5. And then I get K equals 100. So now that I know K, I plug it into the second formula, and I just simplify. And so it's going to be C equals 100 divided by 7.5. And if I do the division, I should get 13.33 as my final answer for the current on this particular problem. Okay, so that's it. That's the last lesson I have for you. I hope that this course has been positive, and I hope that you find out that at the end that we will be very successful on your exam 3. And good luck with all your studies this weekend, and may God bless your continued studies here at CBU.